And all right,
Hi.
okay. Hello once again, ladies and gentlemen. We are back. It is Learn Math with me, Brian Sapinski. As you can see, as time
And
goes
me.
on, we'll put the actual logo up there. We'll try to recreate it there.
I tried to
And
make it here, but it doesn't look like it.
eh, we've got time. We can work on that. Anyway, glad to see you once again, folks,
Sorry.
for day 3 of our live streams to help you guys with your distance learning in math or whatever as things get more interesting, potentially more crazy and stuff like that. So we're ready to get started. Same for those of you tuning in for the first time. Welcome aboard, and just to give you just a refresher as to how this all works. The idea is I'm going to be here for at least the next hour. I'll go as far as 2 hours, depending on who has questions and anything. If you have a math topic you want to jump in and ask about anything in the K through 12 spectrum, nothing is off limits. The live chat is right there waiting for you. So just sign in, say hi, leave a question there in the chat. Tell me what topic you want to look at. And we will post some examples here because we're here, to help you live and in real time as everybody is stuck home. So that's the way it is. Now, before I get to your questions, I want to first begin today.
Sorry about the glitching yesterday, because we were in
Yeah.
the middle of
What?
like doing a topic, and like it started like really glitching out, because like we were doing it in the basement, and it was and like we have like next to no internet, and it ended up like cutting us off really bad. So
So
like the video that it saved, like
yes,
you
a
kind
lot of
of
the
had to be
explanation was cut out. So I just
yeah
want to very quickly
recap.
reestablish the discrete math topic I was doing at the end about weighted voting systems and determining power and stuff like that and winning coalitions and all that. So I'm just going to do this real quick and then we'll get into today's topics. Anybody that has something here, okay? So just to explain again what it was that was happening and the reason for all of all of this loveliness here. Okay, so the
Should
basic
I move it
so
since
no
you're
no no
sitting
no
over
no, you're
there?
fine, you're fine. Okay, all right, but again, here let me just run through this straight from the top from scratch. Okay, so again, the basic premise was that okay, this was a different type of voting where each person's vote within a group, and usually this group usually most often you'd find this in some type of business or just some other alliance or conglomerate or whatever that have to make collective decisions. And the idea is that everybody contributes a different measure of weight to the vote, depending on like their position within the group, how much they contribute into in general, whatever the rules happen to be. Okay, the example that we were using yesterday, we were talking about saying that, okay, we're in the tri-state area here of New York, New Jersey, and Connecticut. Let's say them along with near and dear to our hearts, Pennsylvania. Let's say that they form like a 4-state conglomerate to try to make decisions for new laws of all 4 states. And the idea is that, but what are you doing?
You made
What,
a mistake.
okay, well, I said the move here. Wait, I need that space. Hang on a
Oh,
second.
sorry.
Don't worry, I'm gonna write it all in.
And
I'm
there's the
gonna
weighted
Yeah, very, very good. Yeah, but not that kind,
because
not quite that kind of way. Okay,
because
what did I say? What did I say? Let
it
me.
has like
Okay,
most of
okay. Can I? Let me. Well, let me
sorry.
explain. Okay, so again, here was the premise of the question. Okay, so we said that, for instance, if we go straight by the electoral votes that each state had, we said that New York had the most. It had 29 electoral votes. Then you had Pennsylvania, who currently has 20. New Jersey has 14, and Connecticut's got 7. So let's say that they are going to make a decision with regards to different things. Depending on who says yes to the idea and who says no to the idea, that determines how many voting points go toward the decision. Okay, we gave as an example yesterday, for instance, if New Jersey and Connecticut if they said yes, okay, we added those scores together and they got 21 points. But versus the ones that said no, New York and Pennsylvania, if we add those up, the no's total 49. So the no's win. That means whatever motion was being directed for would not pass. Now, the idea is that in order for something to pass, what then has to happen is that we have to establish, okay, well, here, I got to erase this a second.
Okay.
So the idea was, in order to establish what constitutes a winning vote, you need to establish this number in the front, designated by the letter Q. That Q indicates what is known as the quota. Okay,
and that's how many votes, the minimum amount of votes that it needs to
right, exactly.
Whatever.
And now the quota can't just be any number or whatever. The rule is that the quota has to be at least half of the total points that all of the votes would count for if there was a yes. So we added all four. So we added all four of these yesterday. Okay, and we determined that by adding all four of these, we got a total of 70 voting points in this or whatever. So that means at maximum
35.
Okay, half is 35, but again, there has to be a majority involved in this. So the thing is that you can't just stick on 35, because if it's 35 to 35, that's a stalemate. That does not help you pass a motion. There has to be at least some kind of or at least more than half. Sorry, yeah, at least more than half. Sorry, don't worry, we're clearing up our words as we go here, folks. Okay, has to be at least more than half. So given that 35 is half on the nose, you would need it to be one higher than the halfway point. So that means the quota would have to be at least
higher.
Or 36.
36 or higher.
Where'd you get 65? Okay.
65?
Yeah, that's what you said.
Oh.
Okay, so the quota at its very minimum would have to be at least 36. It could be anywhere from that up to the max of 70. So we gave as an example yesterday, we said, okay, what if the quota happens to be 50? So the object that we wanted to determine was, what are all of the possible combinations of states that could say yes to a bill where 50 voting points were required for it to pass. So, and we came up with yesterday, with four of them. Here, clear the board for a second while I get these, because I gotta put something here.
Here?
We established that New York with its 29, Pennsylvania with its 20, and New Jersey with its 14. That would be yes, because this came out to a total of, if you added up, 63 points. So that was a yes. Okay. We then had New York, Pennsylvania, and Connecticut could have worked, because that's 49 and 7 would make 56. That meets or beats 50, so that would be a yes. We then found that New York, along with New Jersey and Connecticut, would be a yes also, because 14, 7 is 21, 21, 29. We got 50 right on the nose. So that was a yes. And all of these, okay, all of these that we're finding, all of these groups that meet or beat the quota required in order to make it work, these are examples of, what are you doing?
They all need 21.
Okay, well, we're getting to that. Wait, I'm not there yet.
Sorry.
That's why I said, wait, let me do this.
Oops.
Okay, this is an example. These are all examples of what are referred to as winning coalitions.
Also, or you could also call them winning groups.
Okay, well,
but the fancy term is coalition.
Yeah, because you're talking about who is aligning together in order, saying yes in order to try to get this to pass. That's going on. How am I saying hi to myself? Did you do something?
No.
Okay, because it's definitely not me.
Yo.
Okay.
It just says yo.
Beats me. Anyway, moving on.
Maybe
so all of these are winning coalitions. Now the thing is, there is one more combination that also works within this. The one remaining combination, and this should be obvious, is if everyone were to say yes, all four of them, because that would mean you have the full 70 voting points, which definitely beats 50, and that's it. That would be not just a winning coalition. Move over. See, stop that. You're taking away all my space. You're taking all my space. That's why I told you with that. This is not just a winning coalition, but this would be referred to as
the grand coalition.
Yes, because again, it's the one group that involves everybody saying yes, and it goes forward, from there and stuff like that.
I like math.
Yeah.
Now you're saying that you like math.
Yeah, I know that. Okay. All right. Whoever's trolling me in there in the thing, okay, better quit that. Okay, that's not where we're.
Please.
Okay, so we'll see where it is.
Maybe it's just Mom and Joey. Maybe they went onto your
Well,
account to watch it.
why don't you go downstairs real quick and check, and we'll see.
But if it's just a troll, please stop.
Okay, yeah, that's not what we're here for. Okay, we're trying to make.
And plus, if you say something like really bad or rude,
okay, well,
they'll think it's him.
Well, we're not going to acknowledge it and stuff like that. Okay, and hey, listen and somebody in the chat just now. Hey, listen, no, don't worry. I understand. Everybody, you're saying that you don't like math. Hey, it's okay. Everybody comes in with a given with given preferences to their different subjects. And I know math is not the easiest thing for a lot of people, but that's what we're here for. Today, not just for not today's live stream, but every live stream that we're doing here during this time. So listen, just listen, whatever you need help on, okay? Or give me something that's frustrating you, okay? Whatever's frustrating you with regards to math. Give me an example. We'll put some up, okay? We'll try to see if we can help make it easier for you. That's why we are doing this, okay? So please, by all means, jump in and tell me what it is you'd like some help with. That's the story there.
Not Mommy.
Okay, so we'll see what happens with the story is there. Okay, so this is an example of the discrete math that I've been doing with some of my high school guys. I just wanted to repost that one first, just to recap from today. And as I was telling Brianne, this is the reason for all of her drawings, is that in different groups, as the weights are set up differently between the people involved and stuff like that, what happens is, depending on how the votes are, you could see that, like in this case, the New York's vote was involved in all 4 of the winning coalitions, so they would have 4 units of power. Pennsylvania is involved 3 times, so they have 3 units of power. New Jersey's involved in 3. Connecticut's involved in 3. So New York's vote has a bit more weight to theirs versus everybody else's and stuff like that. And depending on how the weights are different, one person could have a lot more power than New York has right now and stuff like that. Or depending on the vote, they may have all of the power possibly. They might be a dictator where if they say no, it's impossible for the thing to pass. There's no way to make it work or whatever. And some people, if their votes are really low, it could mean they have no power at all and stuff like that. It all depends. But this is an example of some of the business that's happening there with regards to the discrete math and stuff like that. What are you doing?
One of this person.
Okay. Have we figured it out? I'm very confused. Okay. So, yeah, I don't know what the story. Okay, well, I can do that. You don't have to.
All right.
So.
Report.
Okay. Well, I don't want to. I want to make sure I'm not reporting.
No, I wasn't doing that.
I understand.
Yeah, and it isn't Joey either. He's just watching his own video. And plus, he barely even knows how to type. Sorry, Mr. Troll.
We will get this. We will get this figured out here. We're trying to get this all sorted. Okay, well, whoever you are, sign in under your own name. Okay.
Yeah.
So.
We don't want people.
Yeah, because I don't know what the story is here. Because whoever you are, you're showing up under my name. Okay,
so then people think it's him, and if you start saying weird stuff.
Well, you guys will know it's it's me if you see the name of our channel here. But okay, but that's all in place there. We'll move on there for now and stuff like that. Okay, but anyway, we got yesterday's business reprised and taken care of. Let's move on to the new business here. Okay, again, anybody that's got questions there in the live chat, throw a topic. Throw a topic out there, whatever topic, math topic you like, anything from K through 12, and we'll put some stuff up while I'm waiting.
I'll throw one at you.
While you're waiting for really.
You told me to throw one at you, so I did.
Fifth grade humor. Fifth grade humor.
You're literally telling me to throw this paper at you.
That's right there. That's right. That's right there with reading the riot act. Yeah. Where is this riot act? Yeah. It's badly written and poorly thought out. Anyway, okay. So what have you got here? Okay. All right. Well, here. Okay. I know that. I mean, do we have something specific here that you like to go through or whatever? Okay. Because let's see. I'm looking through because we mentioned before Brianna's in 5th grade and stuff like that. So she's looking. We're going through her different things there. Okay. All right. Here. I want to get some because I know everything I'm seeing here in the packet. I'm seeing multiplying with multi-digit numbers, dividing with multi-digit numbers, which I know you've done both of those things for. Yes, we are going to get some division videos up with her and stuff like that. So so that will be coming soon. But right now, let's get the current business in position here or whatever. Okay, so you okay. Let's see for okay. Well, here, let's do it from the perspective of you've got some of your word problems here. Okay, we always want to keep working on our word problems, folks. So, okay, just read one of them. I'll take down the main details that are relevant to us, and we'll play out from there. Okay, so what do you got?
If a space shuttle is traveling at 17,460 miles per hour, how fast is it moving per minute?
Okay, so they want to know speed per minute. Okay, oh, that's interesting. Okay, all right, let's see what we can do with this. Okay, so you know that in 1 hour, let's take a look at this the information that we know. Hey, all right, well, welcome aboard, Alex. Okay, glad to see you in there. Okay, you got a question on a topic? Throw it in there. We'll get some questions up for you. Okay, in the meantime, let's take care of this. Okay, so Brianna, so let's consider this. So they're saying that 17,460 miles per hour. That means, okay, just to rehash that, it's saying that you're going this far in the time limit of 1 hour,
which is also 6.
Okay, all right. Well, yeah. What do we know? Well, here, what do we know about 1 hour in relation to minutes? 60 minutes, right? Okay. So the thing we have to recognize here, okay, and this is a very common trap that I see people run into because of the notion that, okay, you're trying to convert from hours to minutes. So the question is, then that it's going to be, that it's going to be either a multiplication or a division, or at least hopefully you do, okay, and stuff like that. Okay, no, that's fine, Alex. That's perfectly okay. No, but like I said, what if you got a question that you think could help somebody on today's work or whatever? Okay, throw out the example and we'll put it up there and stuff like that. That's fine. Okay, I'm just looking for a topic. Anything we could put up on the board for everybody to see. All right. So, but coming back to this, though, Brianna. So here's the question. So we know we've got to do either a multiplication or a division from, with the 60 to the 17,460. So here's the question, though, Brianna. The thing is, when 1 hour becomes 60 minutes, okay, when you're going from this to this, do you have more pieces in it? Yeah, just forget about the time and look at the thing. If 1 is becoming 60, that means you have more fragments of time. Okay, because in the same measurement of time, there are more fragments. There are more minute fragments than there are hour fragments. So as a result, since you're going to have a bigger number coming, are you going to take with the 17,460? Are you going to multiply by 60 or divide by 60? Since there are going to be since there are going to be more units now when you convert hours to minutes.
You're going to divide.
Wait, but remember what you just said. You just said that when 1 hour becomes 60 minutes, you have more units. So if you have more units, you are going to multiply.
Huh.
So you have to see what 17,460, okay, times 60 is going to become. Okay, we'll bring the 0 down because we know the 0 is going to negate everything that's there. Okay, so start going across the business here, and let's see what we get. Wait, what are you doing? No, wait. We took care of this 0.
Oh.
That's done.
Wow.
What 1 0 means it's all zeros. So just go immediately to the 6 and start 6 by 6. Just carry it from right there. No. You don't have to. No, you don't have to go underneath. Just start right from here. Just drop it right there. All right. Okay. Whoa. 6 times 6 is 12. Okay, wait, and let's wait. Let's wait, hold on. Let's 1 second. Let's keep our place values line. Wait, stop a minute. Stop. Let's keep our place values lines up here because you're starting to crunch a little bit. I want to make sure this is legible here. Okay. Put your 6 there. Put your 6 right here. Put it directly under the 4. Okay, now don't crunch here. Okay. So now you're doing the 3 would go here.
Because it's from this.
Oh, I'm sorry. No. Thank you. You're right. Okay. Good. Hold on. Wait. Stop a minute. Okay. No. Because you're squeezing your number in, and it's not falling in line with the place value. Okay. So no. I just need you to see that. Okay. Now do this. Okay. Put your 4 under the 1. Okay. Now from there. Wait. Okay. What goes up here? 4, right? Now 1 times 6 plus the 4, and it goes over there. Wait.
I don't know.
1 times 6 is not 7. Wait, why are you erasing the whole thing?
I don't know.
That's you just did. We're back here. 1 times 6 plus 4 is not 11.
Oh, 10.
Thank you.
Because for some reason I thought there was another one.
All right. So this ends up being now the rate in miles per minute. Yeah. Multiplication division problems, involving conversions of time, miles, and other sorts of things like that. Whatever the case happens to be, you have to watch and be careful with that. You have to be aware of what you have to be aware of when hours become minutes or any sort of thing like that. You've got to recognize that in making the conversion, if you look at the raw numbers, are you converting to a unit that has more fragments or to one that has less fragments? That's going to tell you whether you have to multiply or divide with the number that you're converting from and to and stuff like that. So that's the nature of all of that business, however. So here, real quick, let's just I'll show you another one here and stuff like that. So let me see if there's another one with okay. So Okay, so like you have another question. Okay, here's one that has the same kind of premise here. Okay, you've got a problem here also that says, okay, you got an orchard that's selling cherries here. It says that they sold it they sold in a month. Okay, in a month they sold 7,400 and 40 ounces in the 1 month.
That's pretty good.
Okay, well that's ounces. Okay.
Oh.
What they want to know is what is it in pounds. Okay? That's what they want to know here at the moment. Now they tell you in the problem, they indicate for you exactly what the conversion is. They're saying that there's 16 ounces, okay, in 1 pound. Okay, 16 ounces in 1 pound. So again, here's the question then. You're going from ounces to pounds. Look at the raw numbers. Are you going to
divide.
Yeah, this time you're going to a unit of measurement that has less units than what you started with for the same amount. So this is a division. So this one you're going to do 7,440 divided by 16. So that's how you got to look at the difference there. You have to when you do those conversions. So we have to try to look at all those things. Okay, so you can't put 16 into 7. Okay, so now you're counting, and this is part of. I was talking yesterday about, and again, the video was cutting me. The feed was cutting me off a little bit. We're talking about the idea of fancy counting, which a YouTuber by name of Vihart, VIAH or HART, Vihart. Let me just write it down so you can see it. Look up her stuff. It's awesome. Okay. And there's one video in particular that she did that I refer back to my students constantly called How I Feel About Logarithms. It's an Algebra 2 concept, but there's a core skill that she talks about where she basically takes all basic operations and converts them back to what she calls fancy counting, which means, yeah, kind of like what here, Brand, just step to the side so they can see here. Just so like you see. So recognizing that she's divided, yeah, well, yes, okay, call it skip counting if you want to. The idea is that, okay, you're dividing by 16, so you're counting how many 16s can you count in order to get to 74, or to get to a number that's as close to 74 without going over. Now we're playing the prices right here. Okay. So, yeah. By the way, I tell you, it's weird. It's very weird. I've seen the pictures because now that Let's Make Deal and Prices Right or whatever, that they've gone dark for at least 2 weeks because of all this stuff with the coronavirus. I've seen pictures of what Studio 33, the Bob Barker studio, looks like, completely bare bones empty or whatever. It is a weird picture. It honestly is. It's I'll show you after the broadcast is over here and stuff like that. But no, it is crazy and stuff like that. So, but be that as it may. Anywho, okay, so like show. So we've got so you counted your way to 64, another 16 gave you 80, which put you over. So that was no good. So you counted 4 steps down the line. So you did that.
Wait,
okay.
I didn't finish it.
All right, keep the subtraction going. Okay, so you got, and I'll drop the 4 down in front. Okay, so now we're counting to 104. Okay, your count hasn't reached that, so we continue. So we keep that moving on. Got to 96. Okay, and then you could tell from there. Yeah, no, not 102. No.
I know it ends.
I think you missed a carry. The 2 is fine, but it's not 10 afterward. You forgot it's not 10. Yeah, it's 11. Okay, so 112, which is put you over. So the 96 is fine. How many steps down the line is 96? It's 6 steps. Okay, so we put the 96 under. I'll drop the 0 here, or a little lower. So there. Okay, and you should get You should get 80, which you see on your list there is the fifth one down. So we get 5. So there's your end result. So they ended up selling 465 pounds.
I want to know
So-
how many actual cherries it sold.
Okay, how many cherries are in a pound? That I could not tell you. Okay, because that's going to depend on a couple of factors. Exactly what type of
Maraschino cherries.
Yeah, what
ShopRite cherries.
Yeah. I'm talking. I couldn't even
What?
like so no
ShopRite
wait there's
cherries.
black cherries there's Bing cherries
Maraschino
wild cherries. I don't know. Somebody help me out there. Anybody that sees this, and I'll throw this to my friends
In the comments or in the live chat.
Yeah, I'll also throw this to my friends on Facebook after this is over here. And I'll mark this spot. But just question exactly like how many different breeds of cherries are there, or whatever, and is there such a thing as maraschino cherries? Because just to clear up that question, because I don't think there are, but again,
The ShopRite
if I'm
cherries are
wrong,
just called that.
if I'm wrong, somebody research real quick and tell me here, because we got to because I want to try to figure it out just to answer that question. But the bottom line that I'm trying to stress: what are you doing? What are you drawing? What is that supposed to be?
Yeah.
Oh, you're talking. Okay.
And then it's
When Joey's
yellow.
next video comes along, and
There's gonna
we're
be
hoping.
a cherry skit in it.
Okay, all right. Well, okay. So you have a little preview spoiler for for next time I do a first grade video. You'll know what the heck that's about or whatever.
It's supposed to be yellow.
It's gonna it's gonna be a real because we already experimented with it once, and we're gonna try it again when we shoot for realsies. So it was crazy enough the first time. Wait till you see how it ends up really turning out.
It's because the first time we needed to scrap it because I was yelling too much, and then Dad said something that was inappropriate for first graders.
Well, I mean, it wasn't inappropriate.
He only
But
said screw it.
I think, hey, stop that.
It's true. You said it wasn't that.
Okay, you didn't have to say it now.
It's not like first graders are watching this now.
I'm human too, folks. Okay, just
And
please
plus,
bear with
I
me.
want to actually do it too.
Okay, all right. Well, here. Oh, what am I gonna do with you? What am I gonna do with you? Anyway.
Sorry
Okay.
about that.
All right.
Now,
Okay.
there's the cherries. That's the whipped cream, and then the blue stuff is the Jello. Because for the second time, Joey wanted blue Jello.
Okay. What are we doing with it? You'll have to wait and see. Don't say anymore. Leave it.
Now I'm
Leave
hungry.
Leave that as a teaser.
Now I'm
Okay.
hungry. Now I want Jello. Now I want to eat the blue Jello.
Okay, not now. Okay. So more on that later.
Now
All
here's
right.
a little bite mark.
Okay.
I ate some of the Jello.
Okay.
But I ate the Jello. I'm hungry. Nom. I'm eating the Jello. I'm eating all of the Jello. What?
This is what we have degenerated into, folks. Okay.
Just me pretending to eat fake Jello.
Yes, exactly. Okay. All right. Okay. As I wait for some more things to to put into position and stuff like that. Okay. And again, please keep that. What are you doing? Okay.
Trying to get my papers.
Keep that where it is. Okay.
Paper is under the table.
Wasn't that under the table? But anyway.
Yeah,
Okay. All right. I will hear. Okay. While I'm waiting for some more questions to get thrown out there and stuff like that. Okay. Please keep whatever topics you want to discuss here. Let's keep them coming. We'll get them up here on the board so we can further the explanation on things. While I'm waiting for you guys to ask questions here. Okay. All right. I got a little bit of a challenge for you. Okay. Just a wait. Just a brief little test. Okay. I'm momentarily going back to my discrete business for just a moment. Here's what I want you to do for a second. Okay. Yeah. Just follow this. I'm going to give you the letters. Okay. Now you see this group of letters, A, B, C. Okay.
The
All
first three letters of the alphabet.
Okay. very quickly, what I want you to do just for a split second is I want you to take those 3 letters, okay, and I want you to shuffle their order around. Okay, wait, don't erase this. Just make a list underneath. Just organize them in as many different arrangements as you possibly can. You guys try it too. Okay. Okay, you got those. Okay. BAC, she's done CBA, ACB, BCA. Okay, CAB. Okay, and are there any others you could do?
Is there more?
Well, I'm asking you first. Is there any other way to do it? Okay. Same with A in the front. You did both of those possibilities. Okay. Do you have every possibility covered with B in the front? No, you got BAC already.
Okay.
Yeah. That
Where?
was the first one you wrote down.
Oh.
Okay.
Yeah. I
Okay.
think I think
Okay.
those are
And
all
I'll tell you right now, you did put them all in proper order. Here's how you can tell. So here, how many arrangements do you have on the list?
6.
6. Okay. You want to know how you know you got them all?
Cause all of them have 2.
No. Wait. Well, yeah, no, but here's the more
All of
accurate.
the-
Here's the more accurate way to see it. Okay. In
Because
array.
because like each of them, their letter is in one of them. That into is in the beginning of one of them.
Okay, wait. Well, that's the way the arrangements ended up, but I want you to see why. Okay, because consider this. Okay, when you had to make these 3-letter arrangements, you had to pick a letter to go at the front of the arrangement. So when you're placing your first letter, how many letters do you have to pick from?
3.
You have 3 letters to pick from in the first position. Then once you've chosen that letter, what do you have for the second position?
2,
and then for the third?
And then 1.
Okay, here's what happens. The idea is that, okay, if I multiply those together.
Oh,
Three
it
times-
equals 6.
Okay, there's 6 ways to do it. Okay, what you have just calculated, okay, is it's known as 2 separate things. Okay, this is another discrete and statistics based concept or whatever. So that I'm showing you. This is an example of first of all, what is with all this, what is known as a factorial. Okay, all of this that you see 3 times 2 times 1, that could be shorthanded to read like this: 3 with an exclamation point. And no, that does not mean scream the number. I knew that was coming. You be careful, you. Okay, I don't want you. And thank you for restraining yourself, because I don't want you shattering the eardrums of anybody watching this. Okay, so all right, but that's the way that you do any type of factorial calculation. So just to give you a further example, so if I asked you to calculate this, if I asked you to calculate 6 factorial, here, spell it out the long way, just like this is. So how would 6 factorial read long way? What number? Obviously, what number does it start with? No. Wait. What? Yeah. What's the number that's there? 6. Okay. Just put it here. Go ahead. 6. Okay. All right. Times. Now, no. Yeah. It's going to be a series of multiplications. And what do you notice about the next number that you multiply? Yeah. What do you notice about the next number you multiply?
It's the one that goes before it.
Right. It's the one that goes before it, or one less than that, however it is that you want to call it. So in this case, it would be 6 times 5 times 4 times 3 times 2 times 1. Okay. So here, real quick, in your phone calculator, punch that. Yes. Don't scream. Yes. Do not scream it.
Don't.
We want emphasis, yes, but not that much. Okay. So, all right. So real quick, in your calculator, punch all that in, and you can see if you had 6 objects and you were trying to arrange them all in a specific order, how many orders could you possibly do? Yeah, go ahead. How many does it say?
720.
Could you imagine trying to write out all 720 arrangements of the letters A through F? Could you imagine trying to do that? Nope, exactly. No, you can't. And you probably don't want to. All right, so
That's why it's easier to just multiply all these.
what? Yeah, but I mean, but understand, many obviously computer systems or whatever can very easily come up with all the arrangements and constructions and stuff like that. So, but that gives you an idea. But it's interesting that for as number as little as 6, the multiplications that follow it, you could see the number rises up really, really quickly.
Then,
Would you matter of fact?
what about this?
The number would be so astronomical. Like I said, no calculator could fit. Standard calculator could fit that on its own. Okay, but I said here. I want you to take a guess for me in a second. Here, you guys take a guess out
What
there.
if it has 2 exclamation
There's no such thing as that.
or 3 exclamation points?
Okay, now you're trying a little too hard.
What?
Now you're trying a little too hard.
But what if it has more than 1 exclamation point? Does that mean you do it more than once?
I have no clue because we don't write it that way. So
Don't scream.
that's the story there. Okay, but anyway, but I want you to take a guess at this for a second, and you folks out there, take make your predictions out there too. Okay, you saw that 6 factorial already comes out to 720. Okay, so already you should have enough of an idea that when you bring the 7 into the mix and call it 7 factorial, it's going to be 720 times 7, and that's going to go into the thousands easy. What do you think is the first factorial number that if you take that and multiply it by one less, all the way down to 1? What's the first one you think that will give you a calculation that lands in the millions?
Which
what do you
one?
think? Huh?
Which one?
No, wait, that's what I'm saying.
Random
Like,
number?
no, that's what I'm saying. Like 6 factorial you saw came out to 720. As this number goes up, so too is the product going to be. It's going to start to climb very quickly. What do you think is the first number that if I did a factorial of that number, the multiplicative string would give you a calculation that lands in somewhere in the millions. We break 7 figures. What do you think? Take a guess. Take a guess first before we try.
100.
100? Okay, well, okay, I'll tell you now. 100 times 99 times 98, whatever, okay, you'll go way past the millions and then some. I'll tell you now, the real answer is much smaller than that.
10.
Okay,
Is it 10?
let's see how 10 looks, okay? Because
so
again,
that means
10 would be 10
10
times 9 times 8 times
9,
7 all the way
8,
down to 1. Okay,
7,
punch it in and see what you get. 5. Here, I'll finish this. You punch it in. You punch it in. Punch it in. I'll finish this. Let's see what that comes out to. 10 times 9 times 8 times 7. Just keep on going all the way down. 6 times 5 times 4 times 3 times 2. And look at that. Look at that result you got. 3,628,800.
I haven't even done the times 1, but it
Well,
doesn't matter.
again, yeah, times
Here's
1.
proof.
Times 1 isn't going to change anything.
We used a calculator.
Yeah, and I'll tell you now, 10 is the first number where that would happen. It would, because think of it this way: if you go one step back and do 9, okay, if you go one step back and do 9 and just do 9 down to 1, basically that last 0 that's caused by the times 10 would disappear, and you'd only have 362,880. So 10 is the first time you get into millions. So you can see, even for such a little number, the multiplications cause the calculations to rise a whole lot faster there and stuff like that. So it's pretty crazy. So it's fascinating what numbers can do when you put them to the test, right? It's pretty much there.
It's like a number saying.
Don't test.
What?
Why don't we just put a historical reference on this, and just have the 10 be the head of the snake around the pole, the whole, instead of don't tread on me, don't test on me. We'll do that. And what's with the whoa? The 10's become Keanu Reeves? What the?
No, I'm just saying that it's like this is like, oh my gosh, look at that number. Whoa. What? What?
You're too much, Brianna. You're too much there. Who knows? So, but that's the situation that we got there. So, okay.
I made a little funny math comment. Don't test me.
Or else what? Don't answer that question. So, who knows? It's all crazy there. Okay.
There we go. There we go. I don't get it either.
Where did we lose sight of this, folks? I think we lost our purpose as to why we're here and stuff like that. Yeah. Somebody's asking me a question here on the side here. They forgot what I was up to. So just trying to make sure.
So the 10 is saying you don't test me, and the 10 then grabs an exclamation mark and an equal sign and puts it next to it, and then it like does the thing that we just did there.
Yes. Okay.
And then
could you get up before you
number.
Could you get up before you knock the board over?
And then he turns into that giant number, so don't test him.
Good Lord.
I fell.
Yeah, see, I told you. I knew that was going to happen. So, anyway. All right. So,
I fell again.
We're dealing with a lot of mess here, folks. We're trying here very hard.
Technical difficulties, except it's with people.
Yes, and please.
Except
yeah.
it's with people.
Yeah, the last thing but be careful. Last thing I need is this sucker falling apart here, because then we're in big trouble here.
And then like the computer is gonna get smashed.
Yeah, please. This is the only one I got left at the moment. So let's not
Yes, or else we can't live stream.
Yes, so
Oh dang.
So
Maybe we could do it on Mommy's computer.
Okay, all right. Well, we're running out of computers here, so let's
Yes.
let's get let's be careful not to go a little too far and stuff like that. So okay, all right. Okay, we still got time to fill here. Okay. So we got to see what it is that we can try to pull off here and try to make work here. Is everything looking okay on the? I think.
Yes, everything is fine.
Keep an eye on that.
Wait, can I introduce you to
I want to make
someone?
sure.
I want to introduce you to someone.
Let's wait till the end.
Please.
So let's wait till the end. Hold on. Okay, I have something coming in here that I think could be of help to us. I'm just double checking my information here. Bear with me a second here, folks. Okay, so somebody is. Oh, okay, that's something else. Okay.
There she is.
So I'm just trying to take a look at see what questions other people, including my students, have sent me on something like this. Okay. I mean it's okay. So that's there. Okay. So see that. Okay. So we got that in place here. Okay. Well, thankfully, I mean seems for the most part, I mean, hopefully my geometry guys are doing pretty good and stuff like that. And my discrete got a little extra preview of what it is that they have to do and stuff like that. Let me see. When's the last time you worked on shapes? Okay. Oh, hello. Oh wait.
Ah.
Oh, we got somebody in. Hey, Amber. Good to see you
Hi.
there. Whoever. Here,
Hi.
Amber. Throw us a question here. Okay. We need something. We're
Who's Amber?
yeah. She's one of my students. She's one of my geometry students currently and stuff like that.
Hi.
So yeah. Please here throw out a question. What is it that you're which topic are you working on right now? Throw it out there so we could post a couple of extra questions here. We got to fill some time. So leave a comment for us, Amber. We'll get in place there. Okay, all right. But
It's the smileys.
okay, but and you're drawing those why?
The channel math. The smileys.
In your eyes, but
There's
you've already seen. Okay, all right, but name the topic here so that I can tell everybody else watching in YouTube land. I know you're on day 3, but explain what day 3 means to to everybody else not in our classroom.
Yes, I do not know what day 3 means. And they have green shoes, so they're wearing all the channel colors. And the little thing.
Yeah,
that says
I
learn
know
math.
what you mean. I know what you mean. Stop that.
See, they're truly the channel mascots. They're wearing the channel colors, which is actually just the basic pack
Okay.
of Expo colors.
All right, let me.
Want proof?
All
Here
right.
we go.
Yes,
The
we know
basic
that.
pack of Expos is also channel colors. I'm just
Are
gonna,
you not entertained, folks?
I'm just
Okay,
gonna
all
go
right,
over here.
all right. While you're doing that real fast. Okay, wait. What's
What?
Come back here. Okay, sorry. So here.
I need to cool off.
All right.
Getting
Well,
too
while you're cooling off, let me ask you this question. Okay. All right. What do you know about triangles?
They have.
Oh no, I'm sorry. Okay, no, wait. Actually, hold that thought here. Okay. All right. All right. Parallel lines and transversals. Okay, I forgot. Triangles is is tomorrow with my geometry guys. So all right,
Oh.
let's get into the parallel line topic. Okay, what do you know about parallel lines?
Like, no matter how far they go, they can't touch each
Okay, all right. So you got that. So it goes that far and stuff like that. Okay, so here's a rough sort of sketch and example of that or whatever. Again, ignore the slight artistic imperfection. And by the way, do you know why we put the arrowheads when we're drawing a
That
line? Do you
means
know?
like they keep going on and on and on and on and on and on and on forever.
That's why I said be careful. Okay.
And on and on and on and on forever.
Okay, wait. Okay, hold on. Wait. Okay, stop. Okay, wait. Speaking of that, okay. I know we're talking about lines and distance here, but this applies the concept of going on and on. Do you know what that is when something goes on and on?
Infinity.
Okay, and that applies just as much to numbers as it does to geometric lines and stuff like that. There's
Oh, wait,
I've talked about this with you many times before in the past or whatever.
Here's
A ruler?
Joey.
Check here, Joey. Check. Tell mommy to check my computer bag. I might have some protractors in there. Okay.
And like
I may have a
something
couple of
also
protractors.
about lines, when teachers tell their kids to line up, technically they're not in a line, they're in a line segment.
Well, yeah, because there's a starting point and a stopping point with stuff like that. Yeah, there's a definite number of people. Okay, which no, you know what? Hey, good analogy. I like that one. Okay.
No, it's because like I remember my 4th grade teacher said that.
No, and that's a very good way to think about it.
And
Yeah,
he
no,
said
exactly.
line segment.
Yeah, because there's a
line segment.
Yeah, because there's a definite starting and stopping point. Okay, but coming back to what I was saying about the infinity thing, regardless of whether we're talking.
The infinity symbol looks like this. No, not like that. Sorry. Never mind.
I got an easier way to do it, but I like that way better. I mean, I understand what you're trying. You're trying to do this.
There we go.
Yeah, something like that. Okay, but let me make my point here real fast, okay? Because I like to always refer back to this many times over, and I think a few of my students, I think I actually sang this to earlier in the year and stuff like that. Many many years ago, I've told you before about Square One TV, right?
I think so.
Good. We did the triple play game based on that they did on that show ever. For those who don't know what Square One TV is, if you don't, you should.
Wait, what's
I mean,
triple play?
it go like okay. I'll tell you.
Wait, wasn't that ball game me and Joey played?
No, that was Who's Counting.
Oh.
But anyway, all the stuff that we're talking about coming from Square One TV. For those who've never heard of Square One TV, this goes back. It's a show that goes back to the late '80s and early '90s. It aired on PBS. It was on for 5 years, however, and basically it was take the Sesame Street formula, only remove the puppets. It's all basically all live action people with occasionally some a little animation thrown in and stuff like that. And the entire show should be in the living room. And it was an entire half hour, 5 days a week that was devoted to math concepts. And they did it kind of sketch style, like Saturday Night Live type of kind of thing, whatever. So they did movie and TV parodies. They did it would since it was still the MTV era. They made music videos and stuff like that.
Yeah, so it was
some people, well, no puppets though.
It was Sesame Street, but without Elmo and everyone else.
But it was a half hour every day of math concepts and stuff like that. So like I said, they parodied movies, they parodied TV shows, they made music videos all around math concepts. Some music videos they did with established music stars and stuff like that. Of note, they had a famous rap act from the '80s called the Fat Boys, who came in a couple of times and did songs for them and stuff like that. They had Tempest Bloodsoe from the Cosby Show do a couple of do some stuff for them and things. And they had a few celebrity involvement. But one song that they did, okay. Yeah, I think so and stuff like that. But well, here I'll show you what they look like later. But anyway, come back to point. One of the songs that they made up or whatever, tying to what we're doing right now. Okay, let's not get too much into banter. They did a song about the concept of infinity, and because I thought of it immediately when you said that it goes on and on and on, because that's kind of how the song goes. However, the song basically went like the refrain of it was like this. That's infinity. You can count forever. There'll always be one more. That's infinity. Count from dusk till dawn. You'll never reach infinity. You'll just go on and 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 on. You get the idea, folks. Anyway, okay, all right. Okay, all right, here.
Where is it in the bag?
It would probably be here. Can you help them look in the?
Okay.
Can you help them look for the protractors and stuff, whatever. Okay, I'm hoping they're still in there. I thought they were. Okay, because I know we got a ruler somewhere. Okay, all right, but anyway, coming back to point for you folks. Well, no, wait, it wouldn't be if it's anywhere. It would be in the main bag. It will be in the large where I keep the laptop. Anyway, okay, so coming back to point on the parallel lines here for a second. Okay, now that our music corner is done. So all right, so here's the basic premise here. So what's happening with my geometry guys, and maybe your geometry guys too, is that you've got two lines that are running parallel with each other. Okay. And what happens now is that, okay, we have this third line that is cutting through both of those parallel lines. This third line, it doesn't have to strictly be a line. It could be a line segment too, whatever the case is. This is an example of this third line, what is called a transversal. Again, it just essentially describes any line. And understand, a transversal doesn't have to specifically apply to when parallel lines are in place. It's just any single line that intersects two other ones at certain points. Okay, so even if these two lines weren't parallel, which we'll denote with the arrowheads like this, just to symbolize it.
I didn't see one. All I saw were a bunch of papers.
Okay, I know I've seen a ruler around. Okay, Yeah, we'll try to. All right, we'll try to figure that out after the show is over. We'll do that. But anyway, so here's the deal. As a result of this transversal, what happens now is that at each of the two intersections here and here, what's happened now is that several angles have now been created. Okay, as a matter of fact, there are a total of 8 angles that are in place. So here's 1, 2. Now you can number these in whatever order you want. I'm just doing it this way for sake of argument. But you can see where all 8 of the arguments are all the angles are located. Now, here's the thing. As long as you know that the lines are parallel, the hook here is that if you the hook here is that if you know the measurement of one of those 8 angles, thanks to the fact that these lines are parallel, you would know the measurement of all 8 of them.
Because they're like all straight, so they all have the same. Like
okay, let's
it's
say
like they're
okay.
all squares.
Yeah, no, not well. Not
it's like in a sense they're all squares, so they all have the same like size.
well, okay, but well.
It's like if you connected a bunch of squares that had the same size.
No. Don't think that far.
Don't listen to me.
I know where you're trying to go with it. I understand, but it's not going where you think it is.
Oh,
okay. All right.
okay.
So all right. Let's consider this. Okay.
What I just said.
All right. Okay. Well, let me ask you this. What do you know about angles in general? What kind of discussion have you had about angles in the past? Do you know?
That could be.
Where like the names for them? Right. You have obtuse. Okay.
And right.
Okay. And do you know what the key number is that's associated with all 3 of those?
Wasn't it like 90?
Yes. A right angle is exactly 90 degrees.
And
okay. And the acute is okay.
Joey,
come on.
That's negative.
Okay, but it's under 90.
Laugh at the back page.
Under 90. You can tell what he's been up to, folks.
I love pigeon books.
And it's over 90. Okay, so you got that.
Oh, and
okay.
I love making books.
Okay, so here's the deal.
This is
okay,
an example of
so you know. Okay, all right, Brianna, come on. We're getting off topic here. This is taking too long. Okay, so knowing those facts. Okay, so but the fact that these numbers, you know that's the important thing. All right, so here's what I want to know. Let's suppose that you knew the measurement of angle number 1. Let's say that angle number 1 was 110 degrees. Let's say that was there. Here's what I want to know. Here's what I want to know. Okay. Wait. Angle 1 uses these 2 portions of a line. Okay, you see it? That's where the angle is. All right. Now, and you can see from looking at that, you can see that it's an obtuse opening, and you can recognize, so then it has to be bigger than 90. Here's what I want you to see. Which other angles in this picture are also obtuse? Look at them closely and tell me which other ones appear to be obtuse. Tell them to me by number.
5.
Angle 5 does. Okay, wait. Which one? Angle 3 or angle 5? Because it's not both of them. Angle 5 is. Okay.
And then.
Wait. Take a look. Wait. Look at where 7's going. Look at 7.
Oh wait, no. 7 is acute.
So yeah, 7's an acute opening. You can see it. It's closed further than a right angle would be. So that one.
8.
So that one's still good. But 8 is fine.
8.
Okay. 8 is okay. And is there another one?
No.
Is there another one that appears to have an opening that is wider than a right angle? Because 90 would be a perfect L. Take a look at 6. 6 is like this. That's not that's smaller than a smaller opening than perfect L. So 6 would not work.
So I think that's it.
There is one more. No, you already said 3 wasn't.
It's not 2. It's not 7.
There's only one number left.
4.
So it's 4, yeah. You can see the Y up here. Okay, so now here's my next question to you.
Which ones are acute?
No, wait. Well, we know if those 4 are obtuse, we know the other 4 are acute, but that's not the question. My question to you now is this. At the beginning, I told you that I said, what if angle number 1 was 110 degrees? Okay, so here's my question. Knowing that these other three are obtuse angles, and knowing that you've got the parallel lines, my question is, if angle 1 is 110 degrees, what do you think the measure of all these other three angles are? The same 110 degrees. So 8 is 110, 5 is 110, and 4 is 110. So if you try to look at it, so if you simplify the situation, look at it by size opening of the angles, and I understand figures are not always drawn to scale. That's fine, and so be it. But if you play along those lines as to which ones have in general the same size opening, then you know which angles are supposed to be the same measurement. Again, provided you have parallel lines in the figure to begin with. If you don't, then this argument is null and void. But we're assuming that we've got parallel lines in the situation. Okay, so that leaves the other four angles here, 2, 3, 6, and 7. Okay, so we got those. My question then for those four angles is what measurement all of them are. Now, you know they have to be less than 90, but then here's the thing you have to try to keep in mind. All right, were you ever, aside from acute, obtuse, and right, were you ever told about straight angles?
I think so. That means when they're like
Do you know what degree measurement is associated with a straight angle? Bingo. Yep, you know it.
Yeah.
180 degrees. Okay,
yeah.
so then here's my question.
Doesn't that mean a straight
If you take a
angle
look-
is also can be an obtuse angle?
No.
No.
Obtuse stops before you get to 180. That's the thing. Okay?
Okay, I'm just.
Yeah, it has to be more than 90, less than 180. Okay? So it's really not just strictly, it's not an open-ended it's not an open-ended description. It actually has a range. Okay? But so then here's my question then. If you look, all those other four angles that we have left over, but the thing is, if you connect them to any of the 110s that we have in the first place, they make a straight line. Thus, they make a straight angle. So here's my question then. So basic angle addition here. Follow this. So
Straight line.
right, okay, all right, okay, but answer my question. Yeah, exactly.
Straight line. And then
right, exactly. Okay, but so then answer the question.
I just ruined everything.
Oh, relax, it's fine. So if those are 110, how much are the other ones then? You know that each pair there has to total 180. How much will be left?
The acute angles?
Yeah. An acute and obtuse side by side would have to make 180 degrees. You've got 110 here. How much is left?
Yeah.
70. Bingo. Yes.
And that looks like
and you got it how?
I
You subtracted 180 minus 110. And that's 70 degrees would go in every other location. So it'll be 70 degrees there, 70 degrees there, 70 degrees there. So
if I could choose how much the acute angles did, I would have put it this.
Whatever it is. Okay, but all right. So if one of the acute angles in this picture was 89, that means all the other acute ones would be 89. And what would that make all the obtuses? What will be 180 minus 89? Do a quick check here. And if you got to do a quick check, do the same thing. Always check it for yourself. Check it before you wreck it. 17 minus 8. So the obtuses would be 91s. Okay, so that's all you gotta do. That's all you have to do to try to set that up. That's perfectly the way that it goes here.
I like this because this is like they're each one off.
Yeah, no, I figured you'd like that little twist or whatever. So, okay, but that's the way that pretty much goes. Okay, and then here, real quick, we'll take it a step further here, real fast.
I'm gonna erase it.
Okay.
I'm gonna erase it.
Can I? Here, just all right. So keeping that premise of straight versus, okay, I just want to take it one step further, just get just a little bit of algebraic stuff into it and things like that. So again, we'll put the lines back here. Let's set everything in position. Okay, and let's suppose here, I'm just going to move this down a little bit. Okay, because I want to make sure I've got some space here for my purpose here. So knowing, again, looking at the general size openings of the angles so that you could see, so that you know, have an idea of which ones are supposed to be congruent and which ones are not. Okay, and I'll put the parallel arrows back here just to keep that as a given. Let's suppose that there was some let's say we had some algebraic expressions instead of straight numbers in a couple of the angle positions. Where they are would determine how the equation you would have to set up in order to try to solve for the missing measurements properly. So if we had, for instance, let's say I put a measurement here. Let's say I put here 2x plus 10 degrees in this angle position. And then let's say in this position I put let's say I put in 5x minus I just want to make sure I pick something that works here. Hold on, wait. Okay, let's say I put 5x minus 35 degrees, whatever. Okay, the question is, the first thing you want to determine in a situation like this is, again, just from what we saw on the original diagram, look at the locations of where I put those two expressions. Did I attach these expressions to angles that have the same size opening or different size openings? And it helps if you trace them out. They are the same size opening, yes, because take a look. You've got this one over here. It is open in wider. It's in an obtuse fashion, and so is this one. Okay, so they both have obtuse openings. They're the same size. Now understand, when we do our final calculations with this, the calculations I'm about to give you may not have final numbers that fit the description of an obtuse, but that's irrelevant to the point. Okay, the key here, because again, I'm just coming up with these numbers on the fly. The key here is that you want to recognize, do they have the same size opening? So if you wanted to solve for x in this if you want to make an equation out of these to solve for x, since they have the same size opening, that means that these expressions are equal, meaning the equation you would set up would read as follows: 2x plus 10 equals 5x minus 35. So then you would have to solve this equation from here. So the idea from there then is, since you got two terms on each side, we said this the other day when we had a little bit of algebra, you got to get both sides down to one term. So you have to combine like terms. That means you got to get rid of a term on one side to send it over the other way. So I would send the 2x over to the right side. I would do that by subtracting 2x this way. So how many x's would that leave me? 5 x's minus 2 x's, 3 x's, okay. And then I would have to send this minus 35 over to the other side. I would do that by adding 35. That would be the inverse there. And so I have a positive 10, a positive 35, which gives me
45.
Okay, so now both sides are down to one term. You then, to get the x, so now the x is alone, but it's not single. To make it single, we divide both sides by that 3 that's attached to the x to split it apart and leave us with a single x. In this case, we end up with 15 for the value of x there. So that's what you get for that. And if the problem that you're working on out there, folks, only wants you to solve for x, then good, you're fine, good to go. If it wants you to go further and get the actual measurements of the angles, then you go ahead and do that. In this case, if I plugged it in, let's see, 2 times 15 would give you 30, 30 plus the 10. So both angles are 40 degrees. I know that means it's an acute angle. I wrote it on an obtuse opening, but again,
Doesn't matter.
don't worry about that. Again, for the purpose of setting up the equation, look at the positions they were in. They were in the positions of two angles with the same size opening. That's what mattered.
I have a question.
Now, on the flip side, what if instead, and just to show the other possibility, go ahead.
The angle is like, I'm just making up a random number for it. That's 190 degrees. Would it
Not
look something like this?
Yeah, which we don't deal with that type of angle in this sort of problem or whatever. We would focus on the 170 coming from the other direction. That's where our focus would end up going for that type of situation. You're going to see when you ultimately get into geometry down the later years, yeah, most of your focus with regards to angle measurements are going to focus primarily on the 80 to 180 range, or the 0 to 180 range. Yeah, the stuff that goes beyond that, you really don't focus on until you start getting into discussions about circles and things like that, which is deep down the line. So but at this point in the game, no, we wouldn't worry about that. We just focus on 0 to 180. Okay, so now just to flip what happens in that last problem, what if instead of where they were, let's suppose that they were in different positions. Let's say the 2x plus 10 was still here, but what if the 5x minus 35 was over here instead? So now if you look at the openings here, you've still got that wider obtuse opening over there, but here where the 5x minus 35 is, if you trace that out, you could see that that's on an opening that's smaller than a right angle, meaning that it's an acute. Because of that, Brianna, what would happen is that now, because they're different, that means that they're not equal to each other. If they're different, as you saw in the first problem we did, that means if I took those and connected them next to each other, I would get a straight angle. And we said before, a straight angle is how much?
180.
180 degrees. That means that these two would add up together to become 180. So the equation you would have to set up would end up looking like this: the 2x plus 10 plus the 5x minus 35, and those must add together to make 180. You could. I'll tell you this. If it helps you to put the parentheses on it,
Yes.
in order to just make sure you know where one expression starts and the other one begins, then yeah, sure, by all means do that. You could always use that to your advantage. But I'll say this, it's not an end-all requirement.
Yeah.
Okay. Maybe do it in the beginning just so you don't lose track of everything. But as you get more experience, then you could drop the parentheses and just take everything from what it
Since
is.
this isn't
So
the main equation, I decided to put it in.
All right, so here's the thing. So now we have to simplify this down. Because you have 4 terms on the left side. I said the other day, you can't start trying to solve and cancel until each side has no more than 2 terms. So we've got to combine some stuff here. Combine the 2x terms. You got a 2x and a 5x. That gives you how many x's? 7 x's. Okay. Now, be careful here. You've got a positive 10 and a minus 35 and a negative or minus 35. So because they are different signs, you would have to subtract. Who wins, the positives or the negatives? Who's got more? The negatives have more. So that means your answer is going to be a negative or a minus. Do 35 minus 10. What would it give you?
25. It
will give you 25. So that's what it comes out to. And then you have the 180 right there. From there, everything plays as it did before. Okay, now you start solving. We start canceling things. We bring the minus 25 over by adding the 25. So it gives you 205. Oh, shoot. I had a feeling that was going to happen. Okay. So, okay. And then you would divide by 7. And, okay, this is going to give you a crazy decimal. In this case, okay, it happens in this one. I promise it does not happen every time. Okay. That's the circumstance of the numbers that I invented.
The luck of the draw.
Yeah. That's the numbers that I invented here. So, be that as it may. What are you doing now?
I'm fighting.
This is like, hey, okay.
Okay, he has 10 health points. He has 35 health points. So he's most likely gonna win because he has more health points.
It's rock, and the fact that you're using red or excuse me, yeah. pink or purple or whichever this is. The
That's-
fact that you're using those, it's almost like Rock'em Sock'em Robots. If anybody remembers that old toy from back in the day and
was
stuff
it
like that.
The blue dude versus
Yeah, Red Rocker and Blue Bomber were their names.
were the blue dude.
You remember from when they used to have that thing in Dave and Buster's, right?
Yeah.
Remember that from years
used
ago?
to have like a
when they had those giant ones. They didn't work very well, did they? The ones we had in our Dave and Buster's, they kept breaking down, and they never had they weren't
can I say the mall?
They weren't actually making contact with with each other properly. So that ended up.
Can I say the mall they were at?
That died a quick death where at the.
Wait, can I say?
Where were?
It was at the Palisades.
That was that the Palisades had that one.
Yeah,
right?
the one we go to now is the Wing.
In Willowbrook, yeah, we go.
In Willowbrook.
Yeah.
It's
Willowbrook in Wayne, New Jersey, the Palisades Mall in West Nyack, New York. Those are the big malls we're talking about.
Yeah, it's because where the blue guy fights the red guy, and then.
Yeah, and like I said, if you score the hit on the one robot's head, pops up the neck
like this.
Like that and stuff like that.
Like this.
So.
Like this.
Yeah, exactly.
The face doesn't change, but.
She's making her point there. Yeah, but that's exactly what it is. Yeah, think of it like that if you want to. Yeah, that's exactly if you want to think of it. The battle of positives versus negatives when you're combining them. Yeah, it's.
You have to see how many health points.
Yep. Yeah. So who's gonna win? So that's the story there. So okay.
This is.
Yes. So. Yep.
And then he ends up having. Coincidentally 25
where he goes down to nothing. So negative wins. The champion. Ta-da!
Ow! The way you bent into my arm was like
sorry.
It was like the way it was not supposed to bend.
What do you do, right? So that's it there. All right, so we got that conversation, and see, we get a little bit of everything. Even in discussing a bigger concept, we can still discuss smaller concepts, and as you can see, an unusual or entertaining way to to break them down. That's what I mean. You got to be inventive with this type of stuff, folks. So. Finds a way to to make it more interesting for yourself, more entertaining. Come up with whatever joke or gag that you want to, and stuff like that, to try to help that when you're trying to do this concept later for yourself or any concept or whatever, but that you can think back to how you like to remember it, and that it makes it easier for you to try to go go through the motions and the calculations and solve and stuff like that.
You can even
so
use
that's the way it is.
favorite book character.
Yeah, look who somebody is.
Like Knuckle Bunny or the pigeon.
I like the pigeon.
Okay.
How do you jump?
I don't care.
That's pretty close. All right. Well, here. I'd love to keep this going here. Okay,
Wait,
but
I have someone I'd like to introduce.
You already introduced the Smileys. Who else do you have?
We didn't properly introduce Mrs. Smiley.
Wasn't she already there?
Yes, but
All right, real quick, because we got to sign off here.
Okay. So this was coming.
This is our cool down, folks. While she's drawing them, I'll go through the the usual spiels or whatever. So again, with everything that we've done here, we thank you once again for joining us. And please, as I keep asking you guys and ask you to keep doing, if you know anybody who can go with it, have fun with this this level of entertainment and stuff like that, as we try to teach real math to you guys in real time, where you guys are trying to complete your distance learning for however long we have to do this. Okay, please, I strongly encourage you, recommend this to somebody. Spread the word out so that we can really make the most out of this as much as we possibly can. Okay, and
if you like my tattoo, give this a like.
God.
Even his temporary tattoos, he can't get enough of them, folks. But yeah, but please, if you enjoyed what we did here today in any way, shape, or form, like this video, please subscribe to the channel so you can be aware of not just when tomorrow's live stream goes or when everything. It's like I said, we're gonna be here at 2 o'clock every weekday for as long as we got to keep running with this or whatever. So
Are
just
we in Eastern time? I think.
yeah,
And subscribe.
Yeah, Eastern Daylight Time. Yes. So
and subscribe.
yes, I said that already, Joe.
Oh.
So we got
And make 1,000 likes.
No.
Yeah.
If you like my tattoo.
Ambitious. Joey is very ambitious.
nothing is too ambitious. So we got
Okay.
that there. All right, but yeah,
Wait.
but please keep on joining us, and I promise we're gonna have new regular videos going soon and stuff like that. We're gonna get it all figured out and squared
No,
away.
not yet.
But we got time. We're gonna figure it out here, whatever. I might have a temporary laptop coming to me to be able to try to keep doing stuff. I might be getting a temporary one later today, so to see if we can try to keep things moving. But
Okay.
but we're always going to be here. And yeah, send me an email at brian.sapinski@gmail.com if you want to ask other questions on the side and keep going further. And hey, even if you can't make it to the live stream, send me a question in advance about a topic. Well, I'll make sure I do it on tomorrow's live stream or whatever. Okay. So
Now these two.
you don't have to necessarily be here to do it, but just help whatever out. All right, real quick.
These two are
Johnny.
the Smileys. This is Mr. Smiley. He was basically on every live stream. And this is his wife, Mrs. Smiley. And she also has a blue crown, but instead of having, she still has a red tongue, but she has red lipstick. And then she also has green shoes. And
I'm like confused right there.
And now
If you see me,
You're not the only one, Joe.
just
now
subscribe.
I have a baby, little Smiley.
Do these guys know the Pack family?
Yes, they do.
Yeah, I figured as much.
And
They look like they belong in the same neighborhood.
And I belong at Earth. And look
he
at
has red cheeks,
I'm like confused.
a blue crown,
See me?
and also has green shoes, but lighter green shoes.
Whoa.
He's little Smiley. And
Good
this
enough,
is the
good enough.
Smiley family.
With me in it.
And they're the channel mascots. Yay!
Wait.
In your
And I'm in
opinion.
it. I'm right there.
And what?
If you see me, subscribe this. Hey!
No, he's not there anymore.
And
So,
we're going.
Dad, can these be the channel mascots?
We'll think about it. Okay, you know what? Give us an opinion, folks,
Yes.
or whatever.
And
Comment.
give this a like.
Yes
Yeah,
or
leave it-
no.
Leave
if
it. Leave
you
a
think
leave
they
a
should
comment.
be-
Tell me
And
what
give
you
a
think.
like.
Okay, all right. They know.
Comment yes or no if
They
you
know the
should
rest
be
of
the
what to do.
channel
All right.
mascot.
Okay. All right. But for right now.
And ask if and give this a like if you see me.
They can't see you.
Yes, they can't see you.
All right. Well, here. Okay, but for now,
Be right there.
the Smileys have to wave goodbye, and we have to wave goodbye too. We'll see you tomorrow at 2 o'clock, guys.
Goodbye,
for
kids.
more,
I'll see you tomorrow.
we'll see you tomorrow with more live stream.
Talk.
Screaming.
I just talked. I'm gonna give myself my brown hair.
Let's bring it down. We got to go. Okay,
Yeah,
we'll
we
see you
gotta
guys
go.
tomorrow at 2 o'clock for more live streaming at math action. Okay,
Bye.
take care. We'll see you
And
guys.
give this a like.
We did that already.
We did.
Goodbye. JK.
Do you even